Good day, everyone! Our topic for today is series and parallel circuits.
Today, we're going to discuss simple circuits, their parts, and how to build series and parallel circuits.
At the end of this video, you should be able to first, identify the parts of a circuit. Second, identify the difference between series and parallel connections in a circuit. Third, demonstrate that the brightness of the bulbs depends on the circuit. And last, identify the factors that affect the brightness of the bulb in a circuit.
Before we go on, let me define first what electrical circuit is and determine their parts. The electrical circuit is a pathway for the electricity to flow that carries electrons to create a complete circuit connection. The power source in a circuit that gives electrons is the battery. A switch is something that connects or disconnects the circuit. The load or the light bulbs are the ones that convert the electrical energy process through it to light every time you see the light glows. And the conducting wires are the ones connecting the loop that allows the charge to flow through them.
Now that we know the electrical circuits and their parts, let us proceed the two most common circuit connection, which is the series and parallel circuits.
One of the examples of series circuit is the Christmas light. All the bulbs are connected in one straight path, or when you turn off a switch of the connection, it will be broken entirely and there will be no flow of electrons in the whole circuit. The circuit that we have primarily in our homes is known as the parallel circuit, where they have two or more paths for current to flow through. When you switch off, the other will remain on and continuous flow of electricity.
Now that we know the electrical circuit, the two circuits and its parts, we will now set up the series and parallel circuits. The first thing to do before experimenting is to prepare the materials needed, such as 1.5 volt dry cell, flashlight bulbs, wires, bulb holders, battery holder, and switch. If the materials are complete, then we are ready to go. Let's set up our first connection. We are going to connect both of the connecting wires to the battery holder and bulb holder. Connect the other end of the wire to the switch. Next, we will add the battery in the battery holder, and after that, screw in carefully the bulbs. Turn on the switch. Assess the light of the bulbs. What do you observe? Now that we successfully set up our first connection, how about if we try to add one more bulb? Turn off the switch. Then gently connect another bulb to the circuit. Switch on to see the brightness of the bulb by adding one more bulb. Observe what happened to the light of the bulbs. Does it become brighter or dimmer? How about if we remove one bulb, what will happen? Slowly remove one bulb. Now that we remove one bulb, what happened to the circuit? Did the brightness of the bulb change? Did removing one bulb affect the circuit? Based on the circuit that we built, is it a series or a parallel circuit?
Before moving on to our next setup, close the switch and disconnect the circuits. Now, let's have our second setup.
Let's proceed to our second setup. First, prepare the materials to be used. Assemble the circuit by connecting the wires of the bulb holders to the battery holders. Connect the switch to the battery holders and bulb holder. We have now one set of simple circuit. Get the 4 batteries, then insert it into the battery holder. Make sure to place it properly so that our connection will work. It's time to connect the bulb. Screw it carefully. When everything is done, turn the switch on. You can see that the light glows. What can you say about the brightness of the bulb? Switch off the light. Let's add one more bulb into the previous connection we built. Get another connecting wires and bulb holder. Attach it to the first bulb and insert one bulb. By connecting the wires, we are creating another pathway for the electricity to flow. When everything is set, switch on the light. What can you say about the brightness of the two bulbs? Does it brighter compared to only one bulb? Observe the brightness of the bulbs and record your observation in your notebook. Switch off the light. Lastly, let's add another bulb to the connection. Again, get another bulb holder, connecting wires and bulb. Connect them all together into the connection we did earlier. Screw the bulb and turn the switch on. What did you observe? Does adding the bulb affect the brightness? Does the brightness increase, decrease, or stays the same? Let's remove one bulb and screw carefully the bulb in the circuit. What did you notice? What happened to the remaining bulbs? So based on the second circuit, what circuit connection it is? Series or parallel?
Yes! We're finally done with our laboratory activity.
Did you learn from our activity? We hope that you enjoy and learn our activity for today.
To sum it up, you learned that electrical circuits are the pathway for the electricity to flow that carries electrons to create a complete circuit connection. It is composed of the battery, battery holder, bulbs, bulb holder, switch, and connecting wires.
There are also two common circuit connections, the series and parallel circuit. The series circuit has a single path for electrons to flow, while the parallel circuit has two or more paths for the current to flow through.
We hope that this video will help you boost your knowledge and apply it. We're looking forward to see you soon.
Thank you everyone for spending time with us.